Right, so here this question here, 1 plus I is given as a 0 of px. So to find the correct factor is, since we know that 1 minus I is 0, so that means 1 plus I, its conjugate, is also a 0. A 0 of px. Then the real correct factor that we need to form is pretty simple then, because all we need to do is just find out the sum of roots, and that will be the sum of these two zeros or roots. That will be 2, and the product of roots again, just the product of this the conjugates, and if you expand it and do the right calculation, so you will get 2, and then the real quadratic factor is therefore x squared minus the SOR. That will be 2x, and the POR will be 2, of course. So this is a quadratic factor of px. Now let's move on to part B here, and where we asked to find the value of k. There are two ways to do it. I'm going to choose the second way. Well, the first way is that you can actually take px and then divide px by the x squared minus 2x plus 2, this, because it's one of the factors of px, and then from there try to determine k. But I'm going to use the inspection approach. So what that is that I'm going to write out the px in full, 5x squared 2kx plus 2. Now this is supposed to be equivalent to I can factorize this, and so one of the factors, the quadratic factor, is already determined earlier in A, and this there'll be another quadratic factors, and that is quite easy to determine by inspection, because here we have x power 4, here's x squared. Clearly this must be x squared, and here this constant is 2, here you see 2, so the constant for this quadratic factor, it has to be 1. It's just that what we do not know is this the x term, so let's call it ax, and by equating suppose x squared term, I think that will be useful. Now the left hand side of the x squared of this equation is that 5 here, and this from these two factors we check carefully. So -2, for me to get x squared term, I have to times ax, so I get is equivalent to -2a, of course. And how about here for 2? Oh yeah, I can get another x squared term by multiplying x squared and 1, so that will be +1. And then about 2 here, if I times this, I get x squared term, so it's +2. So in other words, I will be able to show that a is -1. Check, right? And so that means if you actually try to factorize the quadratic expression, you actually have this, and the other quadratic factor is this, minus x plus 1. So since we have this, we can then equate the x term, because our aim, don't forget, is to find out the value of k. So the x term for left hand side is 2k, and if you expand or try to expand by inspection the right hand side, that will be the x squared will be out, or rather I should use here. Here I have -2x, that will be times 1, so I have -2, and for 2 here, if I times -x, so it's -1. So clearly k is, well, negative. Oh, well, might have done something wrong. Oh yeah, this is actually 2x. Okay, so which is negative 4. So k is negative 2 clearly. And the last part of C is that, so to express this as a product of two real quadratic factors, in fact we have done so in part B. No, accidentally. Well, it's as a result of trying to find k. So it means now px is minus 2x plus 2. This is the factor we got in part A, and this is the other factor, the quadratic factor we actually have to obtain in order to find k, and then find all the other zeros. Now here, this expressions, we know the zeros because we form this by using 1 minus I and 1 plus I. So all we need to focus on is this particular expression. And so what are the zeros for this? Well, we can just use the formula. So negative b x here equals to b plus minus b squared minus 4ac over 2a, and our ABCs are 1, negative 1, and 1 respectively. If you try to calculate this and be careful about your calculation, you would get half plus minus I square root 3 over 2. So the other zeros will be these two values, these two complex numbers, and the other two would also be the zero of this polynomial. So hope you try the other questions, and all the best.